Okay, it's time to learn some genetics that Mendel didn't know about. Mendel just happened to find some traits that were, well, they were just real dominant, real Mendelian. Like they would have one dominant, one recessive. Like they would have maybe a tall pea plant and a short pea plant. And then he worked with pea plants all the time, like these little garden peas, Some had yellow peas, some had green, some had, just different things like that. And so he'd had some traits that he didn't come across, or he just left out of his research altogether. I'm not exactly sure which, but those were traits that created a mix or a blend of colors, and then or whatever. And then those that express both traits. And so we're going to look at those today. So this begins our non-Mendelian traits. And they are ones that just aren't just recessive or dominant. And so that's kind of what we're looking at today. And so we actually have 4 of these that we're going to talk about, but today we're just doing 2. And so today's traits are going to be looking at, we're going to just do some color examples first, because those are the easiest to understand or the easiest to explain. And these aren't always going to be like biologically correct either. There's some that I'm using as an example, as a simplified. Sorry, I'm having a little trouble with my document camera, getting it centered in where I want it. I don't know what its problem is. Okay, so with these, we do things a little differently. So normally with your Mendelian traits, if you're like, we had a red flower and a blue flower, and you'd say, well, which one is dominant? And you'd be like, well, red is dominant, and so it gets a capital R. And then that's heterozygous for red, right? And that one is blue because it doesn't have any of the dominant. And so you'd cross them together and you'd find out like what you got. Well, that's not how it works with non-Mendelian traits. There's something called, and we're going to do this one first. So what happens, let me just give you the example. So what happens if you have something that's not just like dominant or recessive, but instead gives you a blend of the two? So let's say that we have, now we have a red flower and a blue flower, but one's not dominant over the other. They are actually incompletely dominant. So they both kind of show up, but neither one of them dominates over the other one. So in this case, whenever we talk about genetics like we did before with chromosomes and proteins, in this case, you're actually seeing both of them expressed. So you're seeing both of them. And that's kind of interesting. However, in the first example we're doing is called incomplete dominance. See how far I can go here. So in incomplete dominance, what you are seeing is you're seeing a blend of both traits together. So that's interesting. Okay. I swear to you, I cannot get this straight and it's really bothering me. Okay. So this is a blend of both traits. Okay. So in our example of red and blue, actually, I'm going to change this word. You can leave yours if you want, but I like the word alleles better. A blend of both alleles are expressed. So now we'd use something called like a base letter. Okay, so we use a base letter. So now we're talking about color. So I'm going to use C's for color. And now I have to give it a superscript. Okay, so then I have to give it a superscript. So I'm going to say, okay, so this one is red and this one is blue. And this one, actually, let's do it this way. Let's say, sorry, I'm a little indecisive today, obviously. So this flower is red. It has the gene for color, and it's using the red allele. Okay, that's what that's signifying. Well, cool. The gene is colorful, flower color, and the R means it's a red flower. So it's using that as its like, can't think right now, as its like allele version. Okay, and this one has a blue allele version. Okay, so then just like Mendelian genetics, you would put your letters together. Notice they're all capital because nobody wins over anybody else. Okay, And then I'd be like, all right, so this one's red, and this one's red, and this one's red, and this one's red. What order I do them in? Whatever the heck order I want to do them in. I don't care. You could do the B first if you wanted. Nothing's dominant. Okay. What did I just make? If it's a blend of both alleles expressed, then these are all purple. Okay, so while you would have your color that is red on one of your chromosomes, one of your genes, one either from mom or dad, you got the red one, and then you have the blue one. But if you put them together, you don't get a red or a blue as if something's dominant. You get a purple, because that is what is incomplete dominant. So both of them are expressed. Okay, so that's how incomplete dominance works. These are not going to be the best edited videos because they have to come daily. Okay, so incomplete dominance. All right, so incomplete dominance is a blend. So in that instance, you are going to have blue and red equals, I just did the R first again just because, and then whenever you would actually write up, so this is a genotype, right? So the phenotype, you do blue crossed with a red yields purple. Blend, like you're pouring two colors of paint into the paint bucket. Okay, so that's type 1. Second one we're going to do is called codominance. Co means both. They are both dominant. They are both equally dominant, not to the point where like incomplete dominant, like they didn't quite make it to dominant. So you didn't see red or blue. You saw a blend between them because neither one of them quite made it to dominance. No, these are both dominant. And so here's the kind of, well, I don't know if it's nice. I don't know if it makes it nice, easier or harder. So here's the deal with this. Oh gosh, maybe I should put my parents on first. So let's cross our purple flower. So this was so that one, let's say that one was, well, let's do, oh gosh, I don't want to give you the same example because then you might think that it can change. They're either codominant or incomplete dominant, or like Mendelian, they're like complete dominance, like total dominance. So let's say that this is a cow, and you have a cow that has kind of the red color like the roan, and then you have the cow that's a white color. So you have a white cow, I'm sorry, not roan, red. You have a red cow and a white cow, okay? And together, they make a roan cow. And a roan cow is one that has both red hairs and white hairs. So if you went and looked at its coat, it would be like red and white. So in this instance, you have red crossed with white equals red and white, both. They're both expressed. Both show. Okay, they're both expressed. Okay, and that's what co means. So if you think like co-ed softball, that's like co meaning like both boys and girls, not like some blend of a boy girl. Co-pilots, you have two pilots flying, they're both there. It's not like some blend of a pilot or something like that. Okay, and so that's the difference between incomplete dominance and codominance. Okay, those are both non-Mendelian. All right, so hopefully that helps, and you will have practice problems in your self-grading worksheet. So make sure that you do those so that you can make sure that you know if you're doing it correctly or not. Okay, have a great day. Stay safe. I'll see you soon.